This is a problem from your lab, section 3.5, number 1. We want to find the derivative of this function. This function has an arcsine or sine inverse. Y equals sine inverse of 9x plus 1. So this function is a composite of two functions, so we're going to use a chain rule. The outer function, the derivative of the outer function, and we have to evaluate it by the inner function, times the derivative of the inner function. So in this function, the inside function is going to be the thing that's inside of the arcsine, or the sine inverse. That's 9x minus 1, or 9x plus 1. And then the outside function is going to be our sine inverse. Let's see if they take arcsine. Yep, they do. So it's the arcsine of the function. Generically, we're going to put x in here, but we know that in the actual function there's a composition, so there's a 9x plus 1 in there. But for observing what the function is, it's going to be the arcsine of x. So the derivative of the arcsine function is going to be 1 divided by the square root of 1 minus x squared. So that's one of those derivative formulas that you're going to need to know and remember for your future endeavors in calculus. And so when we do the chain rule, we're going to have this thing, 1 divided by, well, I'm going to put something that's not quite correct yet here. So this isn't quite correct. And then the chain rule says we're going to take the derivative of the inside. So the derivative of the inside, 9x plus 1, the derivative of that is 9. And then the derivative of the plus 1 is 0 because it's a constant. So the change that we need to make is that instead of an x in here, we actually have the inside function. And so the inside, remember that the chain rule says we want to take the derivative of the outer function and we want to evaluate it by the g of x, the inner function, the inside function. And the inside function is 9x plus 1. So in here we're going to get 9x plus 1. Now you can FOIL this out and then simplify it if you want, or you can just leave it as is, and then we should still get the same result because they are mathematically equivalent. Now, in terms of trying to do the derivative again, if you had to do the derivative again, you may want to actually work out and simplify this to what they have. But in terms of just finding the derivative, I think keeping it simple would be fine. So, okay, I hope that works.